Morning, everyone. Let's go ahead and get started. It's 11 o'clock. Imagine more people will be coming in as we progress through this. Just a quick introduction of who I am. I'm Blaize Stewart. I'm a senior consultant at Wintellect, and you can see me online at blaize.net or follow me at The One Mule on Twitter. We also have Wintellect.com, and you can follow us, Wintellect collectively, at Wintellectuals, and then Wintellect Now, which is the online streaming service for developer content, for training, and that nature. You can go to wintellectnow.com and follow us on Wintellect Now on Twitter as well for all the latest and greatest updates there. Today we're going to be talking about containers on Windows Server. So the purpose of today's topic is to give an introduction to the new technology that came out on Windows Server 2016, and we're going to look at the kinds of containers you can deploy and how to do that using some of the tools available to you. So what are containers on Windows? Well, Microsoft has worked closely with Docker over a period of 2 years to develop containers on Windows. So Microsoft formed this tight partnership with Docker because they wanted to enable containers on Windows Server, yet have Docker tools manage those containers. So what they did is they came up with a way to do that without having to use something like a virtual machine and then run containers inside that virtual machine. Because traditionally, Docker has been a technology that came out of the Linux community and has only been able to run on top of Linux. But here recently, with the introduction of Windows Server 2016, now you can run containers natively on Windows thanks to this partnership with Docker and Windows and the Windows Server team. The server offers native support for Windows and HyperV containers, and we're going to talk about what the difference between a Windows container and a HyperV container are in a moment. But the main thing I want you to focus on right now is that the offering here is that these APIs can be accessed through Docker and to deploy these kinds of containers. And these are not Linux. These are not containers that are running on a Linux thing. So these are native Windows containers running on Windows. So they use a different operating system as the underpinning. They use different schemes to get those up and running. But the familiarity of Docker is and the APIs and the command line that you have within the Docker environment allows you to manage these containers in a unified fashion. And the common features that can be applied to all containers, so you can actually build all the Docker tools, Docker Compose, Docker build, use all the familiar Docker commands to actually run and manage these containers. So let's talk about the different types of containers that you can use on Windows Server. The first kind you can use on a Windows server is what they call a Windows container. Now, a Windows container runs Windows processes in a container while sharing the kernel of the underlying operating system. So if you looked at this diagram on the right here, we're talking about this side right here. Now, each one of these containers has an app running in it, and then each one of these containers has something about it that is a Windows app. Now you can use, these are all running on top of bins and libraries running in the user mode on top of a host kernel. So what you might deploy inside of this app would be some kind of runtime, and then with that runtime you would install on top of that runtime some kind of application. So you could install maybe .NET, for instance, and run a .NET application inside of one of these containers. Over here, we have on the right, we have a HyperV container. A HyperV container, what it does is actually installs inside of the container a kernel, like an optimized kernel, and then this kernel is isolated from the actual underlying operating system. So the HyperV container has its own kernel as well as the bins and libraries, and then on top of that, the actual app itself. So the architecture for this is a little bit different than what you would have inside of a traditional Windows container. So these would run on top of Hyper-V itself rather than sharing the actual host kernel like a traditional Windows container does. So that's the difference between a Windows container and a Hyper-V container. For all intents and purposes, though, they can be used in a very similar way. The difference is going to be what are your desired outcomes for these types of containers. So with that in mind, I want to talk a little bit about the Docker architecture for this and how that relates to these various kinds of containers. The Docker architecture running on Windows is very similar to the architecture running on Linux. You have the Windows kernel underneath, and that Windows kernel could be very down low level in the kernel space, or it can be a little bit more elevated, what we have depending on the type of container that we're actually running. And the Docker engine is deployed on top of the Windows kernel here, and then depending on the container type, it depends on what you get, whether you get a Windows container here or you get some kind of Hyper-V container here. In any case, with the Docker engine running, you connect to that with your Docker client. You have all of the underlying hypervisor running there, and then depending on what kind of container it is, depends on the kind of abstraction you get. So the Docker architecture looks very similar to what you would have inside of a Linux based container environment, but the difference here is this is all running on top of a Windows server. So when do you choose a Windows container versus a Hyper-V container? The biggest difference between a Hyper-V container and a Windows container is the level of isolation. Like I said, the Hyper-V container has its own kernel that gives it a high level of isolation. So that level of isolation is really the end game that you're trying to go for. So if you want a highly isolated application and you don't want it to share any of the underlying kernel, then you would deploy a Hyper-V container. Now, this does come out of cost because a Hyper-V container has a lot more overhead because it does have its own kernel. And the idea here is that you actually have your own kernel space, your own application, and everything running directly on top of Hyper-V without that, with a lot less shared underlying kernel here. And so these containers, it will be a lot larger in size, but you actually can get a performance boost by running a Hyper-V container because it isn't sharing an underlying kernel. However, with a Windows container, these are built for scale. So the idea behind a Windows container is density. What you want to have is, as these are much smaller in their size, so they can deploy a lot more of these in the side of a containerized environment than you would otherwise be able to in a Hyper-V container environment. So depending on what version of Windows that you have installed depends on actually how many of these you can actually install on top of that kernel for running. Like I think under Windows Server standard, you can only do up to 2 Hyper-V containers, but you can do as many Windows containers as you want to. But if you're running something like a Hyper-V instance on top of Windows Data Center, Windows Server Data Center, you can have as many Hyper-V containers as you want, but you would be and as many Windows containers as you want. The level of isolation, though, is and the level of size, depending on the type of container, is really what you're going for, depending on what you're running here. Now, for most intents and purposes, Windows containers are probably going to suffice for most workloads that you're going to be running on top of Windows. And this is really what I'm going to focus on a lot of the demos, because if you need the Hyper-V isolation, though, you can deploy these Hyper-V containers. So it just depends. If your security requirements are such that you need that isolation, go for Hyper-V. But default to Windows containers if you can, because you're going to get a lot more density, and you're going to and you're not going to necessarily see a big improvement in performance if you run a Hyper-V container. So that's really the difference between all of those. So I want to switch over and actually start working on some demos now. I have 3 demos, and I'm going to work through these demos to show you how these actually work and how these deploy. So I don't really have a lot of slides to click through, so the demos are going to be the main thrust of the conversation that we have today. So let me get out of PowerPoint here, and let's go over to a demo. And this demo I'm actually going to run on top of a virtual machine that I have running here. And my first demo is actually going to deploy an IIS instance to a Docker container, and then I'm going to upload a index.html to that container and then to modify it. So this is the Docker file. I'm going to assume that you might have a little bit of familiarity with Docker. However, I'm not going to assume that completely. That what a Docker file does is allows you to take a base image and then take that image and then customize it for your liking, for your application, whatever it may be. So the base image that I'm going to be building from is Microsoft's IIS image. Now this image is available on Docker Hub. It's a generic IIS image. It's a Windows container with IIS already installed inside of it. What expose will do is then take this image and expose the port 80 on top of this, and then it's going to add in some content to this particular image. So I've got a folder here where this Docker file exists, and it's got an index.html in it. And this is my index.html. It's just a hello world, very basic index.html. So what I'm going to do is I'm going to run this Docker file on top of Docker engine that's already installed on top of this, and build an image on top of this and import that index.html. So let's go to my desktop where I have this folder, and you'll see there is my IIS demo. Okay, now if I go Docker images, I'm going to get a list of images here. Okay, Docker images, this gives me a list of all the images I have, and this is just a list of some I've created and some cached images. The one I'm going to deploy is this one here. Notice the size of this because it's got a lot of stuff already installed inside of it, and it's got a full-blown stack inside of it for deploying an IIS web server inside of it. So if I want to build this image, the first thing I'm going to do is I'm going to Docker build, and I'm going to say I don't want to cache this. No cache, and I'm going to give it a name, a dash tag, and I'm going to call it IIS-demo, and then I'm going to tell it to use the local Docker file that I just showed you, and this is going to build that particular image. And notice what it did. It took that IIS image that I already have downloaded from Docker Hub, exposed the port, and added in that index.html. Now I'm going to run that, Docker run, give it a name, IIS-demo. I'm going to expose a port, so that's what the -p directive does, port 8000 to port 80. So this maps the external port 8000 to the internal port 80. Let's do the port 80 since I don't have anything else running on this box. And then I'm going to tell it what image to use, and since I called it IIS-demo, that's going to use that newly created IIS demo image. And now that's up and running. I'm going to flip over to a new command prompt here. I'm going to Docker images, and here's that image I just created just a few seconds ago. And I'm going to go Docker ps-a to show you all of the containers I have running on this particular box. So to get the IP address for this container, I'm going to go Docker inspect IIS-demo, and that's going to give me the IP address that was assigned to this container. Now, because this is running on top of Windows, it's going to expose that IP address directly to me, so I have it available inside of Internet Explorer. And if I run this, you should see my hello world index.html there. So that is actually communicating with the container that I have running inside of this Docker image. Now, if I shut that container down, and if I do Docker stop IIS-demo, it's going to shut that container down. If I try to refresh this page, it won't work. It's going to give me a not found error or something to that nature because that container is no longer there. So this is communicating with that container. So if I start it back up, and I should be able to communicate with it again. And Docker ps-a, it's running. And if I go Docker inspect, I got a new IP address that time. And I can plug that in. and I get my same Hello World application running on top of that IIS container that I just deployed. So that's my first demo. My second demo is going to be about pushing containers to Windows, pushing an app to a Windows container. Now, what we just did is we used just a pre-built IIS container previously. I just pushed a generic index.html. That was using IIS. However, with the new emergence of things like microservices and this paradigm for deploying web pages and applications to containers, you might not want a full-blown IIS stack installed on it. We saw the size of that image was rather large. So what Microsoft has done in response to that is they've created a new version of .NET called .NET Core. And .NET Core is a very, I would say, stripped down. It doesn't have all of the features that a full-blown .NET stack has, but it's got enough to deploy a small website or a small .NET application using that framework. And you can use a .NET, a very minimal .NET container with the .NET runtime core, .NET Core runtime installed on it with your application, and it's much smaller than a full-blown IIS container, which is in the neighborhood of something like 9 gigabytes. And these are much smaller and have a much smaller overhead because they don't have all of the other runtimes that an IIS container would have. So I'm going to go back over to my virtual machine here, and I'm going to load up that. I'm going to create an application and then use that application to deploy that application to a container. So let's go back and let's create a new application. I'm going to call it .NET new-t, and this is going to use a web template. And so it created a new application. Let's go to, let's make a directory first so I don't get it on my desktop. Just call it demo app, and I'm going to go cd demo app, and I'm going to go .NET new-t web, and that's going to create a new directory with a lot of other, it's going to build the scaffolding for that particular app, and I'm going to call it .NET Restore. And this is going to install all the dependencies inside of this application. And I've already downloaded all these dependencies. And so once .NET Restore is run, it's going to install all the dependencies I need to run this particular application based on the template. So it's a full-blown application when I create it. And so once I have it up and running, once it's restored, I can go .NET publish, and this is going to publish this particular application to a folder inside of this particular app in the folder I just created. So this is creating a full-blown .NET application on .NET Core, and it's creating all the dependencies into a publishable folder. Now that publishable folder is what I can actually use to deploy into a container. So I'm going to flip over and I'm going to show you a Docker file while this builds. So if I pull up this Docker file here, you notice here that I'm using another container called .NET NanoServer. NanoServer is an addition of Windows Server that's much more reduced. It's just enough server to get you up and running without a lot of the overhead. So it doesn't have any kind of anything beyond the bare essentials that you would otherwise need to have a full Windows Server. But then it installs with this, it installs the .NET framework on top of NanoServer. And this particular image is what I'm going to base this other image on. So this particular Docker file, what it does is builds on top of this smaller image called NanoServer, sets the entry point. This is the execution point for whenever I create this, the container from the image. It says run.net and pointed to this particular DLL. Now, this DLL is the name of the app. It tells this is a parameter that I need to pass into the image, and then it creates this particular, so that .NET knows where to expose this, and then it exposes port 80, and then it copies the content of my folder to that particular image. So let's come back over here and check the status of this. This is where it published it, so I'm going to take this right here, And I'm going to put my Docker file in this folder so I can publish to this particular folder. So let's go over here to this particular folder. And you notice it's got all the dependencies already installed, plus all the content that I had otherwise put in there. And then my intro point is going to be this app here, this demo.app.dll. So I'm going to take that, and I'm going to change this Docker demo right here to Docker demo Docker app.dll. And I'm going to save this Docker file to the folder that this created when I published it. So let's come back over here and go to Docker file, make sure that it doesn't have the txt extension. So now I'm ready to deploy this to a container. So if I come back over here to this folder and cd to that folder there, and I go dir, there's everything I need to run this particular app. So let's go docker build, and I'm going to tell it no cache, and I'm going to say, give it a tag name. I'm going to call it docker-app, and I'm going to tell it to use the current folder, and it's going to look for a Docker file inside this folder. And that's going to take a second to build based on this particular image. And it's uploading all of the content to the Docker engine as we speak, and then it's actually building the image right here. Notice that it's using that .NET Nano server. It's setting the entry point to .NET demo app DLL. It's telling ASP.NET where to expose that, and then it's copying all the content into to the folder that it needs to copy into this particular container. Now it does take a minute to build this because there's a lot more going on here. So if I go Docker images, I should see my Docker app here. So I'm going to ps-a, and I have that IIS demo running on port 80, so I'm going to shut that one down. I'm going to go docker rm-f iis-demo, and that's going to shut down that particular demo. And I'm going to create a new one. I'm going to go docker run. I'm going to call it --name docker app, and I'm going to say -p. I'm going to tell it to use port 80 :80, and then I'm going to say use docker, the name of that image I just created, and that's going to create a new container based on the one I just built from my application. And notice that it's up and running. And let's go back to my other command line here, and let's do docker inspect. Let's just see if it is running. ps-a, there it is. And docker inspect to get the IP address of this particular IP, so I know what I'm running, and I can pull this up in Internet Explorer once I have that run. So let's launch this and point it to that, and I should see the default landing page of the application. So this is the default landing page that ASP.NET creates whenever you do .NET new and you use the web template. Now you can replace all this whenever you write your .NET Core application. This is just all the scaffolding that it creates for you. And so this is a .NET 1.1 running on this particular container right here. So that's my second demo here, and I can show you a different way to do this. I wanted to look at this one. I can shut it down and you notice here that it's reporting back all the various things that it was downloading from it and reporting back. It's logging things to the console and what have you. And you can shut it down. So I can docker stop docker-app, and that's going to shut it down. And if I try to reload it, it won't reload. It'll just give me an error. So I have nothing running now, and that container is not working. So that's my second demo that I wanted to run through. For my third demo, I wanted to run another one. This one is going to be running from Visual Studio, and I wanted to show you Docker. I wanted to show you Docker and Visual Studio running on Windows 10, and what you can, but you can use the exact same kind of mechanism that you would otherwise use running in Docker. You build an application in Visual Studio to deploy it to Docker as if you were deploying that in Windows Server as well. So you can use a Windows container to deploy these various things as well. So this one I'm going to actually flip over to a Windows 10 VM, launch Visual Studio, create a new project, publish that project, and then run the similar process to what we just used whenever we were just using the command line. So you can deploy .NET Core applications on Linux, but you can also deploy them to Windows containers as well. So let's go over to my other VM, and we're going to launch this particular VM right here. On this one, I already have .NET open. So what I'm going to do is I'm going to create a new project. I'm going to create a new web application using ASP.NET Core web application right here. I'm going to call it Web App 4, which is fine. It's just going to create a new one right here. I'm going to say web application. You can enable Docker for enable Docker on this. I don't want to do it for this particular one because the Docker integration that comes on Visual Studio 2017 and 2015 is more for the Linux containers. It doesn't have the Docker integration installed for all of the other types of Docker integration as of yet. I've tried this to use Windows containers using Docker for Windows on this particular box. Now, Docker for Windows on Windows 10 allows you to switch between Windows containers and Linux containers. So it assumes that you're running a version of Docker for Windows that only has Linux containers. And for the most part, that's going to work. For our purposes, though, I'm going to use Windows containers, and that's what I'm going to use here. So I'm not going to include Docker support right here for this particular application. I'm just going to create this application without that integration. You can add it later by right-clicking and enabling Docker support. What I want to do here is this is just creating a bare bones web application inside of Visual Studio. So this is very similar to what you would have done if you were using .NET command line using the template there. So if I go to, once this is up and running, I can build it, run it, do all that, the same kind of stuff that you would otherwise use using .NET. So if I run it under IS Express, it's going to run this on Windows on my debug here. I was running in debug mode on my particular box that I'm running right here. So I've got all of the dev tools, everything installed on this dev box, and running a full-blown web application in debug mode using Visual Studio. And it's giving me all the metrics, all the cool stuff that you get with a .NET application. And now once this loads, it should load the landing page that you have that you would otherwise see with a .NET application that we saw earlier. It's the same one because this is still a .NET application that we saw earlier. So it's the same scaffolding. The difference between this one and the other one is this is just using an older version of .NET Core. I think this is using version 1.0, the other one is using 1.1. So if I kill that and stop debugging here, you can see that it's running, and I'm using everything inside of Visual Studio that I would have otherwise had. Get the same kind of telemetry I was getting back and so on that I was getting back from the instance that I was running inside of a Docker container that I created using the command line. So once I have the application up and running and I want to publish it, I can build this and I can publish this web application to a folder. Now, this is going to do something very similar to what I did when I said publish before. I published it to a folder, and this one I'm going to publish it to a folder on the file system. Rather, you can push these to Azure, or you can push them to an Azure virtual machine, or you can do some custom Azure web app, or you can push it to a Azure virtual machine. I'm going to publish it to a web folder on my file system, and I'm going to deploy it to a container from there, to a Windows container from there. So Once I have it set to a file system here, I'm going to go publish, and this is going to run the same publish routines that I would otherwise had when I was running it on a Docker container. Now, I have installed on this particular Windows 10 box, I have a Docker for Windows installed. Notice I have this option to switch to Linux containers. I have this running under Windows containers right now because that's the one I want to demo. But if I wanted to publish this to a Docker container, I could do that as well. The Linux Docker container, I could do that as well, but I want to publish this to a Windows container. So now that this is published, notice that it published to this folder right here. I'm going to take this and I'm going to put this, I can open this inside of this folder right here inside of Windows Explorer. So if I come over here and paste this right here, this is the same folder that I would have otherwise had if I was using the command line that I saw a minute ago. So I can use something very similar to what I did before and publish my application using a Docker file. Notice what I have here though. Notice the base image that I'm using here. I'm doing from Microsoft.NET 1.0.1 runtime nano server. This is a different image, different base image that I'm running from. This is using nano server on from Microsoft. I'm going to set a working dir to app and expose the same kinds of things that I had before and set my entry point. The difference here is I'm going to use this .NET 4 and Web Application 4 DLL, which is the name of the entry point for my particular app here. So if I sort this by name, I should be able to see that particular DLL. That's the entry point for this particular application. So let's save this file to this publish directory right here. And I'm going to call it Docker file without the txt extension on it, because that way it'll play nice with Docker. And then I can come back over here and change directories to that. And you can see here I've got that directory here, and I go dir Docker file. There's my Docker file that I just created. And so I can go Docker build, very similar to what I did before, build an image. My app, and then I'm going to say use the current directory. So this is going to build, should be tagged, not tagged. No. It's going to build that image from my Docker file. Okay, there it's building my image. And this is taking a minute to run just because it's got a lot of going on inside of that build process. It's copying all the content, all those DLLs and the content in JavaScript and HTML when it builds the scaffolding for the application into the image and sets the entry point. And now let's go ahead and run this one just like I did before. Docker run, and I'm going to say give it a name. Call it name. I'm going to call it my app. I'm going to -p 80:80, and then I'm going to give it tell it what image to run. I'm going to call it use my app image, and then that is going to build and run. It's already built the image. I'm going to run this as a container now, and it's got to boot the image up, and then once it's done, it'll tell me that it's actually running inside of this particular application. So let's flip back over, and I'm going to need Docker images and see that it actually created that image right here. Here's that one I just created, and then I'm going to do Docker ps-a. This should give me a list of images that I'm running right there. And if I go Docker inspect my-app, that should give me the IP address I need to connect to this particular application. Okay, now I'm going to launch Edge here, and this should pull up that same landing page that I saw whenever I launched the application under IIS Express when I was running it in debug mode inside of Visual Studio. And see here it's running inside of that container right here. It's taking a minute to load because this is running on a machine that's got a lot of additional stuff beyond the bare essentials that you would have inside of a server. Okay, there it is. There's my landing page, and that's the actual application running inside of the container that I have running on this particular Windows 10 box in Visual Studio that I created from Visual Studio. Now to publish that to a Docker on Server 2016, you would run the same. You take that publish folder, push it to your Windows Server, and then run the same Docker file on Windows Server, and you could deploy it in during the same unified process that we just saw. So it's very similar, depending on whether you're creating the application in .NET Core on the command line, or whether you're using Visual Studio to create the application. You can use the both and to do that. Or if you're just pushing a regular application like we saw with IIS to that particular, you can push IIS to that and deploy even traditional .NET applications on an IIS container. We didn't do that, but you can provision that IIS to run a full-blown .NET stack inside of a container as well. So let's go ahead and minimize this. I wanted to open up the floor to questions if there are any, and from there, I know maybe you have some running down here inside the questions. I'm going to pull the questions up, and then we can go through the questions. So please, if you have questions, put them into the questions box, and I'll try to work through those. I just have one question. Where did the environmental variables you define in the Docker variables come into play? The environmental variables inside of a Docker file are used during the build process and whenever you run the container. So whenever you have a container running, when you build the environmental variables, you specify inside of the Docker file. You can specify it there, and that whenever the actual build process on a container is running an instance of the container. So you're actually running the container, and those environmental variables are set inside that container. And then whenever you run the image, when you create a container from the image, those environmental variables are also set there as well. So you actually have both environmental variables on the build process and in when the container is running. Now, depending on the application, those environmental variables are going to have different meanings or different contexts. Like in the ones that we were just running for .NET, I have to specify where that application is running so that ASP.NET Core knows where to expose those particular ports and where to expose the application. So I told it to expose it on all available ITs on port 80, and then that would also expose those. And then I mapped the external port on Docker to that internal port on port 80, and so everything is connected that way for the environmental variables. Next question is, are Docker and Windows containers available on Windows 2016? How about Windows 2007, Windows 2012? Docker containers are only available on Server 2016. It's a new feature to Server 2016. It is not available on Server 2012. So if you want to use it, you have to use Server 2016. And it's available on all editions of Server 2016. And it's also available on Windows 10 for dev purposes, like we just saw. You can, it has to be the update edition from in 2016. But the Server 2016, depending on the edition, depends on what level of support it will have for them. Like Windows Server standard will only support, I think, up to 2 Hyper-V containers and as many Windows containers as you want. But if you run Data Center Edition, you can have as many Hyper-V containers or as many Windows containers as you want. So depending on the edition you run, depends on the level of containers you run. And even I think in Nano Server, it gives you the ability to even run containers there as well. So if you had a Nano Server running on, say, Azure, you could deploy Windows containers on that environment as well. Next question. Can you build .NET apps on a Windows virtual machine and create a Linux image that can be deployed in a Linux machine running Docker images? Can you build and publish a .NET application on a Windows machine and create a Linux image that can be deployed on a Linux machine? Yes, you can with .NET Core. You cannot do that with .NET 4.5 or .NET 5. It's got to be .NET Core in order to deploy a .NET app. So I want to make sure that you understand that .NET Core will run on Linux, and it'll run on a Linux container. You can actually run it on a Linux VM as well, but you have to run it at .NET Core. So it's limited to that version of .NET, but you cannot have a full-blown .NET 4.5 running inside of a Linux machine. However, if you want a full-blown .NET application, whether it be .NET 4, .NET 4.5, 4.5.1 or ASP.NET 5, what have you, you can deploy that on a Windows container, not a Linux container. So depending on what version of .NET depends on whether or not it'll actually run on a Linux machine or not. So Docker can run any of those, just depending on the version of .NET that you're actually running. So hopefully that'll answer your question there. Any other questions? So another question from any recommendations on running SQL Server on Docker? SQL Server will run on Docker. I don't have any particular recommendations on that because it's a fairly new thing, so it's more of a run at your own risk type thing right now with SQL Server on Docker. Microsoft is supporting it, and it does run on a Docker container. My suggestion to you would be hold off on deploying it into a production environment until they've got the ability to have it scalable. Because right now, I will say that Docker on Windows is SQL Server on Docker is a little new, and there's some quirks about it. But I think in time it will mature to the point that it will be available on Docker, and it will be a real production-oriented thing. Like with Docker, databases in Docker are generally not a good idea if you're deploying large production applications in Docker. For that instance, you're not going to realize any kind of benefits from running databases on containers in general. So whether it be SQL Server, whether it be Postgre, MySQL, the general consensus, and you can run databases in containers, is to not use containers for databases, but to use a database as a service platform. So if you're running Azure, for instance, you would run Azure SQL Server rather than run a SQL Server instance inside of a Docker container. Or if you're running SQL Server on premise, run SQL Server on a Windows box, not in a container. That way you can get all the benefits of it. As of right now, that's kind of the conventional wisdom, is not to use containers for databases, although you can. And in some instances, that's probably not a bad idea to do, considering that if it's a small database, maybe you just have a small application, you don't want a full-blown Windows VM running a SQL Server instance, or database as a service is much too robust. You might just want to deploy a single Docker and container running a single small instance of SQL Server. That'd probably be okay. But if you're going to build a large scale that's going to be hit by multiple people over, or you're going to build a distributed app, I would use database as a server or a dedicated instance of SQL Server for that. Any other questions? If not, I will I appreciate you guys attending this, and we'll conclude this. It's been a shorter webinar, but it's been, I think, hopefully been beneficial to you guys. Thanks for coming. If you have any other questions, please feel free to email me at bstewart@wintellect.now, bstewart@wintellect.com, sorry, or check me out on Twitter. You can post something there, or you can post something to my website as well. And this wraps up the Windows containers on Windows Server for now. And thanks for attending, and hope to see you guys on a future Wintellect webinar.